Yep. So the first part that we're gonna do is right here. Okay. So this is 6.1, and 6.1 is the greatest common factor and factoring by grouping. The greatest common factor and factoring by grouping. So the first part that we're going to do is greatest common factor. First, there we go. What is factoring? Factoring is actually the opposite of distributing or multiplying. And it is taking apart a number or a polynomial so we can see which terms made up its product. That's what factoring is. For example, what are the factors of, oh, I have my pencil here, yeah. What are the factors of 48? So this is the first example. So what are the factors of 48? What are the factors means, in other words, what are the numbers multiplied to 48? What numbers multiply to 48? That's what we're trying to find. So let me say 48. We will do 1 times 48. We could do 2 times 24. We could do 3 times 16. We could do 4 times 12 or 6 times 8. And there are many more factors. Okay? But when we're going to be factoring, we're going to be looking at the greatest common factor. And the greatest common factor is just what it states. We will be looking at the largest factor all of the terms have in common. So I'm going to write down here the largest factor of all of the terms have in common. That's the definition of the greatest common factor. So first we're going to do an example with monomials, and then we will factor polynomials, and we will be finding the greatest common factor. So let's do this one. Let's do the first one. Let me move this up here. Give me more room. Yep. So it says find the greatest find the GCF greatest common factor of 32 x to the 4 y to the second, 48 x to the third y, and 24y squared. 32 x to the fourth y, 48. Yes. So what we're doing here, what we're going to be doing first is we're going to write each term in its prime factors. So let's do it. First, we're going to write each term. Prime factors. Let's do that. So let's start with, let's do 32. X to the fourth, y to the second. Okay, so we know that 32 is going to be 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2. So it's going to be 2 to the fifth power. I have 1x, 2, 3, 4, and I have 1y and 2 y's. Okay? Now, let's do the next one. 48. So 48, x to the third, and y. So 48 is going to be 2 times 2 times 2 is 8 times 2 is 16, and 16 times 3 times 2 will be 32, and 32 times 3, hold on, how many 2's? 1, 2, 3, 4. 1, 2, 3, 4. Not this one. This one will be a 3. And I'll show you how to get this. Okay, give me a second. Times x, 1, 2, 3, and 1y. Remember the tree method that we used to use before? I'll do it here. For example, 32. So I always said half of 32 is what? 16. So this is the prime number. Half of 16 is 8. Half of 8 is 2. Half of half of 8 is, hold on, 32. Half of 32 is 16. Half of 16 is 8. Half of 8 is 4, and half of 4 is 2. Those are the prime numbers. Why did I circle them? Because the prime number means that you cannot multiply it anymore, only by itself and by 1. That's why it's a prime number. You cannot really divide it more. So we have 1, 2, 3, 4, 5. So we said that 2 to the fifth is the same as 32, and that's what we did here. 1, 2, 3, 4, 5. The same when we do 48. Half of 48 is 24. Half of 24 is 12. Half of 12 is 6. And half of 6 is what? 3. 1, 2, 3, 4. So we have 2 to the fourth times 3. And if we were going to do 24, which we did it, half of 2 is 12. Half of 12 is 6, and half of 6 is 3. So we have 2 to the third power times 3. Okay? So now, let's go back and finish this. And we had one more, which is 24. And we know that 24 was what? 1, 2, 3 times what? Times 3, right? That's what it was. 2 to the third times 3. And what do we have? I will write the y here. 1y and 2 y's. Okay, so now let's find the greatest common factor. This number is on all of them. The 2 is on all of them and is on all of them, right? So we're going to have 2 times 2 times 2. The x is not going to be because the x is not on this one. It needs to be on all of them. And we're going to have 1y. So my greatest common factor is 8y. And also, you could see here, 8 times 4, 8 times 6, and 8 times 3. That's the highest number that goes on all of them. And in terms of the values, which we're going to see that, you'll see the x is not going to be because it's not in this one. It needs to be on all of them. And the y's, we take the one that has the lowest exponent. That's the one that is going to be the greatest common factor. Now, let's do so any questions on this one? When you're going to be factoring and getting the greatest common factor, you might not be doing this. You will be doing this in your mind, okay, as you go. But I'm just showing you what's going on. What are you doing? So let me do this other exercise. This one says, factor 20x cubed y minus 10x squared y squared plus 35x. Isn't it 20? Yeah. So first, we're going to find the GCF, greatest common factor. So let's do that. So we're going to start with 20. So we know that if we do the 3 here with 20, we have divided by 2 is 10, divided by 2 is 5. So 20 is 2 to the second times 5. Isn't it? I'm going to do the other numbers. 10 will be divided by 2 is 5. So 10 is 2 times 5. And let's do 35. 35, we cannot divide it by 2, so the next one will be by 3. We can. By 4 we can. By 5 we can. Divided by 5 is 7. So it's 5 times 7. Now that I have this, let's go back here. And this one is going to be 2 times 2 times 5. Okay? And I have 1, 2, 3 x's and 1 y. And let's do the 10. The 10 is going to be 2 times 5. I have 2x and I have 2 y's. And 35 is going to be 5 times what? 7? Or 7 times 5, it doesn't matter. 1, 2, and 3. There we go. So now, greatest common factor. It's going to be, what number is on all of them? The 5. 1x and 2x on all of them. So 1 and 2. And that's it, right? I don't have anything else. It needs to be on all of them. So my greatest common factor is 5x squared. I just found the greatest common factor. Let's do the next step that comes after doing that. After we do that, we're going to factor 5x squared out of each term. Okay, we're going to do that. So what we have, so we had 20. I'm just writing the exercise again. So here's my greatest common factor, which is, I'm going to use a different, let's see if this is my greatest common factor. Now I'm going to factor it out. So what is this part that is going to go here? What is going to go in this parenthesis are the elements left over. Whatever was left over from here is what is going to go there. So 5x squared, when I take the 5x squared, what do I have left over? I have a 2 times 2, a 4xy. So 4xy. That was what it was left over on the first term. Let's go to the second one. The second one, when I took this out, what did I have left? A 2 and a y squared. And on the last one, what did I have left? A 7 and an x, plus 7x. So I just factor out this polynomial. The first part was finding the greatest common factor. The second part is factoring it out. And these elements, like I just said, are the leftover. Those are the elements that are going to go there, okay? Go ahead, write it down. Sorry. Go ahead and write it down. Any questions on this one? Okay, do we always do it this way? No. But it helps. It helps to see it this way first. Yes, it does help a lot. You're not always going to do it like this because it takes longer. Like I said, this part is going to be done in your mind. For example, what's the greatest common factor between 12 and 16? We know it's 4. 4 times 3 and 4 times 4. Okay? For example, if we have we're being given a squared b to the third c and a to the fourth, b to the second. Okay, find the greatest common factor. We know right away that it's going to be the lowest one for a is the second power. For b, here's 1, 4, and 2, so it's going to be 1. And for c, oh no, I'm sorry, this is 3. b to the third power. B to the third power, so it's going to be b to the second power. And c is going to be, oh, and this is to the fourth. Okay, b, c to the second power. All of the ones, when we have an exponent, the greatest common factor is going to be the term that has the exponent, the lowest exponent. Okay? Let me give you more examples. 12x squared plus 9 plus 15x. So let's factor those. So right away I know this is 3 times 4, 3 times 3, and 3 times 5. So I'm going to factor the 5. Do I factor the x? No, so just the 5. 5 is my greatest common factor. Not 5. What am I doing? 3. 3 is my greatest common factor. 3 is my greatest common factor. So what do I have left here? I have a 4x squared. I have a 3, and I have a 5x. I found first my greatest common factor, and then I factored it out. Okay? Then a to the 4 minus 2a to the third power. So this is 2 times 4, this is 2 times 1. So let's get the greatest common factor first. It's going to be 2. And between the a's to the fourth and to the third, we know it's going to be the lowest one. This is my greatest common factor. Now I'm going to factor it out. If I take the 2 and a to the third power, I get a 4 and an a out of the first term. And on the second one, what do I have? I took the whole term. When I take the whole term, what do I write down? A 1. When I don't have anything left, I write down the 1. So let me know if you guys have any questions there. Give me a second, I'm gonna get more. Hold on. Okay. No questions? Let me just get more lead here. All right, so now let's do this factor. It says let's factor 7x, x squared plus 5y minus x squared plus 5y. Hold on, 7x. So the first question that we're gonna ask ourselves, how many terms do we have here? So I'm gonna write down the question. And we said that we have how many terms? We have one term and another one. So the answer would be we have two terms. And we need to remember that multiplication and division can take place in the terms. So I'm going to write that down for you guys. Remember,
So it's determining the amount of terms that are inside the parentheses? Like, is that how you got two terms? Or is it just like X and Y?
no, this is one term.
Okay.
Go ahead, Emily. What was your question? Say that again.
Like, how did you determine that it was like two terms? Because like, didn't we do like, wasn't a few chapters ago or units ago, it was like how many terms, and like a term would have been defined in between like addition signs or subtraction signs?
No, we say this is a term because just like I was writing down, multiplication and division can take place inside the terms, just like now. So this is not, this is a whole term because it's one thing here. This is
Okay.
multiplying this.
Okay.
Okay? Let's wait and see. Division. So division can take place in terms. Now, the next question. What do the terms have in common? What do they have in common? In other words, what is their GCF? Out of right here. So then the answer will be the GCF is what? What is on both of them? X squared plus 5y. That's my GCF. Okay? So then if I take the GCF, let me write it down again. So I have plus 5y hold on. So then I have, let's write down the 1 there. So first, this is my greatest common factor. This one. So if I'm going to factor it out, it will be x squared plus 5y. Okay? So this is my greatest common factor. Now, what is the leftover? Leftover is going to be the 7x minus the 1. There is a 1 here always. And this is what we call the leftovers, okay? Which is the 7x and the 1. And we're going to be doing this many, many times, so you'll see it. Now let's do, oh, I got a couple examples here. So it says factor, and we have 8b times 2y minus 3. So again, this factor, right? So it's a to the third power plus 2y. That's my greatest common factor. What is left over from that term? AB and a 1 from this one. Okay? Another one, if they said factor, hold on, let me, this is a 5. 5b minus 7 plus 4. So what is my greatest common factor? This one. So let's get it out. 5b minus 7. Greatest common factor. And what is the leftover? 3k plus 4. Okay? So we just learned to find the greatest common factor and to factor it out. Now, are we fine with this? Okay. Now, we're going to be doing factoring by grouping. All right. So when we started, we said that we were going to do 6.1, which is the greatest common factor, and factoring by grouping. Sorry, I'm factoring by grouping. So we're doing factoring by grouping right now. Okay. So factoring by grouping requires that we generally have 4 terms. Why 4? Because we will be splitting the 4 terms into 2 groups of terms, and you'll see that. So we always need 4 terms because we will be splitting the 4 terms into 2 groups of 2 terms. So let's do the first one. It says we're gonna factor xy minus 5x plus 2y minus 10. We're gonna do it step by step, this one, okay? So first, we are going to split into 2 groups of terms. So the first step that we're gonna do, step 1, is we're gonna split into 2 groups of 2 terms. That's what we're doing first. And that means right here. All right, that's what we're doing. So we're splitting the xy minus 5x plus 2y minus 10. We're splitting it into. Okay, now the next step number 2, we're gonna factor the 2 terms of the first group. We're gonna factor the 2 terms of the first group. Okay. How do we do that? Right here, we're going to factor this. What would be the greatest common factor? It will be x. What is left over? Y minus 5. This is going to continue here. So I just factor the two terms of the first group. Now, the step number 3, what do we do? Or we could have factored them. You know what? We could have factored this one too. So we factor the second term of the first, the two terms, factor the two terms of the first group. We did that, and in step 3, we'll write the leftover factor on the other side. Okay, let's do it like that. We're gonna write what we call the leftover factor. So that means that we're gonna factor this one, and what do we have? Our greatest common factor is going to be 2, right? So it's going to be 2, and will be, my leftover would be y minus 5. Careful is that when you multiply this one back, because here we have a plus, when you multiply 2 times y, you're going to get 2 times positive 2 times y. And when you
can't see your video.
2 times negative 5, you get negative 10. That's what we need to make sure. When you do the greatest common factor here, that when you multiply it again, because that's what you're doing when you're factoring, when you're finding the greatest common factor, you're doing the same thing as if you were, like we said at the beginning, that factoring was actually the opposite of distributing. So right here, we're going to distribute again. We just found the greatest common factor. We're going to distribute and see if the signs match, and they do. What was your question, Emily?
No question. The video disappeared for a little bit.
Oh, okay. And then, so that's what we have now. There we go. We're going to have to, what's the greatest common factor here? It's on both of them, right? So my greatest common factor, which is just our final, that will be y minus 5. What's the leftover? X plus 2. So again, we find again another the greatest common factor between these two terms is y minus 5, and the leftover is x plus 2. And this is my answer, the final answer. Write it down, and I have another one to do for you guys, okay?
So you could also take a different terms, I think, couldn't you?
Different term or terms with?
Yeah, I think you took the first two terms. the first pair and the last pair, right? What if you took xy and plus 2y and then 5 minus 5x and minus 10? Would that work too?
Oh, you're talking about taking this one first and this one second? Is that what you're saying?
Yeah, could you do that too?
No, I don't understand. Why would you do that? If this is what they're asking you to factor, so this is the order that is being given.
So it has to
Unless,
go by the order.
not by the order, but I guess in this case, we don't need to rearrange what is given to us because we can find a greatest common factor between those two and those two. So we don't need to do that right now.
Oh, okay.
Just take it as it is, yeah. Okay. Now let's do the next one. The next one says factor there we go. So then what do I do? Again, split into two groups. All right, I just did it. Let me find my greatest common factor. Out of this one is going to be x squared. What do I have left? 1x plus 5. Let's find this common factor. It's going to be 3. I have left an x and a 5. This is fine because everything is positive. What is my greatest common factor here? X plus 5. What do I have left? X squared plus 3. And I just factored that polynomial by grouping. Go ahead and write it down. Let me know. Now, let's go on to you know what? Let's do this one that is a little bit different. Let's do one more factoring, okay? By grouping. So this one says 12ac minus 8a minus 3c plus 2. Okay? So I'm going to it has 4 terms. So I'm going to, and they're asking me to factor by grouping. Okay? So then between these two terms is going to be 4a. That's going to be my greatest common factor. 4a. What do I have left? I have a 3c minus 2. If I'm factoring out 12ac minus 8a, that's what I have left. Now, out of this one, I don't have anything in common. I don't have any they don't have greatest common factor. So I'm going to write it down here, but hold on. when I'm writing it down, when I bring this negative sign down here, what is going to happen? When I multiply the negative 1 times 3c, I do get the negative 3c here. But when I multiply the negative 1 times 2, I don't get the plus 2. So this one has to be a negative. In order for me to multiply negative 1 times negative 2, it's going to give me a positive 2. So be careful. That's why I did this one. And I said when we multiply, we need to make sure we get the same signs.
So wouldn't it be negative 3c? It'd be negative 3c2, right?
It will be, what is inside of the parentheses, it will be 3c minus 2.
So, but why wouldn't the negative sign go to the 3c?
Oh yes, yes. If you were going to, distribute the negative 1, so then you get negative 3c,
Okay.
and this one will be plus 2, which is exactly as what we have here. You see? It's exactly the same. So that's why I changed from positive to negative. Okay? Now, what is my greatest common factor? Three c minus 2. And what do I have left? 4a minus 1. Okay? And let me see if I have another one like that one. Yes, I do. Yes, let's do another one of these ones, okay? So we have there we go. Now, we're going to factor by grouping. So we're gonna divide it into groups. What's my greatest common factor from here? Just the x. What do I have left? I have the 2 and 1x, and I have the 3y. We're okay factoring, right? Getting the greatest common factor out. We're okay with that?
Yeah, but weren't we? I'm sorry for asking so many questions.
No, it's fine, Emily. No.
So why did we? Because like last time, weren't we doing the greatest common factor in the parentheses? Like for the other ones, when we found the greatest common factor, we were doing it in the parentheses, and then for the ones that were left over, we were doing it out of the parentheses.
You're talking about what? Let's go back here. X.
Wait, I might be okay. I'm wrong. You're right.
What? That's okay. Now, right here, there is no greatest common factor between the two of them. So if I write down the 2x minus 3y, I bring the negative down. Remember, there is a 1 here. So what happens? When I multiply this one times this one, what do I get? Negative 2x. And when I multiply negative 1 times negative 3y, I get a positive 3y. Are they the same? Is this part the same at this one? No, right? So then I know this term needs to be positive. okay? Because when I'm gonna multiply, redistribute that -1, so now let's distribute it again. -1 times 2x is gonna give me a -2x. -2x is here. And -1 times positive 3y, it will give me a -3y. Now I have the same terms. So this one needs to be positive. Okay? So be careful with that sign there. And here's my greatest common factor, which is 2x plus 3y. And what do I have left? X minus 1. I have another one that we could do like that one. Yeah. Three W plus 4y minus 12y squared minus 16wy. Okay. So they said factor by grouping, so then I'm going to divide it. What do I have left on the first one? They don't have anything, right? So it's going to be 3y plus 4y. Now this one is going to have, we know that 4 times 3 and 4 times 4. So I know it's going to be 4, my greatest common factor, and w. I'm going to factor it out. What do I get? I get a 3w, and right here I get a 4y. Now, I need to bring this sign down. So when I multiply this one, -4w times 3w, what do I get? -12w squared, or squared w, okay? Now, when I multiply this one, -4w times this number, 4y, this needs to be what? Needs to be positive, because when I multiply -4y times positive 4y, I'm going to get -16wy. So this one needs to be positive. Now, the two numbers, the two terms, 3w plus 4y, here's my greatest common factor. And what do I have left here? A 1 minus 4w. And I just factored that out. Okay, now let's go to, so we're on 6.1 and we're going to be doing 6.2. So 6.2 is going to be factoring trinomials. Factoring. And there are three ways that we could do it, and we're going to do that. The first one is the sum and the product method. The next one is I use the box method. I don't use the AC, but I could show you both. And the substitution method. This is when we have a trinomial. So that means a polynomial with three terms. So let's do the first one. The first one is We're going to factor a trinomial by the sum and the product method, okay? So, if you guys, we were doing factoring by grouping because we had 4 terms, right? And then we split it into 2 groups of terms. But now we're being given a trinomial, and trinomial has 3 terms, and we're asked to factor it. So most of the trinomials we will be asked to factor will have a specific form, and they are going to look like ax squared plus bx plus c. This is known as the quadratic, as a quadratic function, okay? Quadratic functions are in the form of ax plus bx plus c. Functions in this form. Where a is not equal to 0. So let's go in. In the last part that we were doing by grouping, we were combining like terms, right? It typically didn't matter what order the terms were written. With quadratics, it matters. So you're going to start with the square of the variable. Next is going to be the term with the variable to the power of 1, and followed by a constant. And in the factor, when we're factoring quadratics, we will need to pay attention to the value of a. When there's no coefficient of the square term, which is this is the coefficient, and the coefficient is equal to 1, that's when we use the sum and the product method. So we use this one. It's being used when there's no coefficient of the square term, meaning we're talking about the a, meaning that the a is equal to 1. When this a is equal to 1, we're going to use the sum and the product method. And let's do the first one. The first one says, oh, sorry. The first one, I didn't turn it off. Let me give more space here. So it says, we're going to factor x squared plus 9x plus 18. Okay? And we know ax squared plus bx plus c. So a is equal to 1, b is equal to 9, and c is equal to 18. Right? The first step is to find 2 numbers. So the first is to step 1. We're going to find 2 numbers that have a sum of what? Of B, meaning 9, and a product of C. Okay? So we need to find two numbers. First one, that when we add them, we get 9. And when we multiply them, we get 18. So right here is going to be what? Positive 6 plus positive 3, right? When I add, I get 9. And when I multiply them, I get 18. They are positive. We need to use the same two numbers for both the sum and the product. Now, step 2 would be take the two numbers found in step 1 and write it in the form of x plus the first number and x plus the second number. So we're going to take the two numbers found in step 1 and we're going to write them in this form. We're going to do x plus the first number and x plus the second number. Okay? So that's going to be like this. X plus the first number was 6 and x plus the second number. Or x plus 3 and x plus 6. So 3 plus 6 is 9 and 3 plus 6, 3 times 6 is 18. So the order of the numbers, it doesn't matter. Does not matter at all. And we just factor. Okay, so write that down and we'll do another one. So this one says factor x squared minus 11x plus 24. So again, A is 1, B is negative 11, and C is 24. So I need to find two numbers that when I add them, I get negative 11, and when I multiply them, I get 24. So that's going to be negative 3 plus negative 8. That will give me what? Negative 11, right? And this is the sum. And if I multiply the same numbers, what do I get? Positive 24. So how do I factor? So they tell me to factor this polynomial. So it's going to be x minus 3 and x minus 8. Okay? I'm finding two numbers, and when I multiply it, I get 24, and when I add them, I get negative 11. Those two numbers were negative 3 and negative 11. Let me give you one more here. It says factor x squared plus 3x minus 54. All right? So again, my a needs to be, this coefficient needs to be 1 in order for us to do the sum and the product method. B is 3 and C is negative 54. So I need two numbers. Then when I multiply it, I get negative 54, and when I add them, I get 3. So they're going to be negative 6 plus positive 9. That will give me positive 3. And if I multiply these two numbers, what do I get? Negative 54. So here's the sum and here's the product. So if I do that, it's going to be x minus 6 and x plus 9. Remember, you could write down the x plus 9 first and the x minus 16. And that's going to be the answer. So we just did it using the sum and the product method. I have one more where we need to any questions on this one? Let's do one where we need to find the greatest common factor before we apply this method, okay? And this one says factor 3x to the third power minus 9x squared. This one doesn't look like exactly like a quadratic, right? No, it doesn't. So let's try to factor out the greatest common factor first. Okay? We're gonna try to factor out the greatest common factor first. Okay, let's try to do that. What is my greatest common factor here? Is 3x. This is my GCF, okay? Greatest common factor. So what do I have left? I have x squared minus 3x minus 10. I just factor out the greatest common factor out of this one. That's it. Now, I could apply the sum and the product method here. Just don't forget to carry the 3x all the way to the end. So I need to find two numbers. Then when I multiply it, I get negative 5, and when I add them, I get negative 3. And that's going to be, if I multiply negative 5 at times 2, that will give me, if I add, sorry, that would be negative 3. And if I multiply them, that's going to give me a negative 10. So it's negative 5 plus 2. So let's do that. Don't forget the greatest common factor there. So this one is going to be x minus 3 and x minus 10. Okay? So I will say that you always need to check and see if you could do it. You could find, when you see this, right away, see if you could find the greatest common factor and factor it out right away. And then you could just use the sum and the product method. Now, let's do the next method, which is, the one that I use is the box. The box. Go ahead, Emily.
Why is the answer x minus 3 and x minus 10? Why is it not x minus 5 and x plus or whatever.
Yeah. Yes, thank you. I don't know.
I was just
Thank you.
so much.
Negative 5 and plus 2, right?
Yeah.
Okay. Mm-hmm. Thank you. Now we're gonna do the I didn't write that down there. Yes, I did. Yes. Let's do this one. The next method. So we just did it using, we're factoring trinomials. The first method was the sum and the product method. We're gonna do the second method. And the second one, I use the box method. You could use either. I will show you with both of them an example. Okay? I like the box. I find the box a lot easier and faster. But hey, it's up to you guys. Oops. Okay. So let's do this one. We've been asked to factor 4x squared plus 5x minus 6. So going back, just go back a little bit. We know what to do when we have a coefficient of 1. We know that we're going to apply the sum and the product method. When we have a coefficient of 1 here, we use this method. And when we don't have a 1, we're going to use the box or the AC method. And let me just show you how it works. So let's do the box first. So the box says we're going to just write down a box here. We're going to write the first term here, 4x squared, and the last term here. Okay, so we're going to multiply 4x squared times negative 6. That will be negative 24x squared. And we're going to multiply this 2. And then we need to find a number that when we add it, two numbers, is going to be 5x. Those two numbers are going here. So what do I do? 24. Let's start with 24. 1 times 24 will give me 24. 2 times 12 will give me 24. But it's not going to give me 6. And 3 times what? 8 will give me 24. And 3 minus 8 is going to give me 5. So those are the two numbers that I'm going to use there. Those are my two numbers. I need to find two numbers, and when I multiply it, I get negative 24x squared. And when I add them, I get positive 5. So those two numbers are going to be, this is going to be negative, and this is going to be positive. Okay, so I'm going to add them right here. Negative 3x and 8x. When I multiply these two, what do I get? Negative 24x squared. When I add them, what do I get? Positive 5x. Now, I'm going to take this row. I'm going to do rows and then I do the columns. I'm going to find the greatest common factor in the first row. The greatest common factor in that first one like right here. What's my greatest common factor here? It's going to be an x, right? What's my greatest common factor between the 8x and -6? That's going to be a 2. Now, let's take this column. What's my greatest common factor here? It's going to be a 4x. And what's my greatest common factor between these two? It's going to be a 3. Okay? Now, if I multiplied this one, x times 4x, what do I get? 4x squared. If I multiply x times 3, what do I need? I need -3x. So that means that this is going to be negative. X times -3x will give me -3x. Now, if I multiply 4x times 2, 4x times 2, I get the 8x. If I multiply the 2, positive 2 times -3 will give me a -6. So this one doesn't change. This is going to be a positive one. This is the one that is going to be a negative. So my two terms are going to be right here. You got the answer here, x plus 2, and you got the answer here, 4x minus 3. That's it. That's the box method. We'll do more exercises of this one. If we want to do it by the AC method, let me show you how to do it by the AC. Any questions on the box? No, guys? Everything is fine there? The AC on the same exercise. Okay, with the AC, we will have to, we have 4x squared plus 5x minus 6. So A is equal to 4, B is equal to 5, and C is equal to -6. So first we're going to multiply. We need to multiply A times C. So we're going to multiply A times C. With you get 4 times -6, -24. Okay? So now we need to find two numbers whose sum is 5 and whose product is going to be A times C. So let me write this down. In the second part, we need to find two numbers is B, and the product is A times C. So we need to find those two numbers. So it's going to be positive 8 plus -3. That will give me a 5. That will give me b equals to 5. And then two numbers, the same numbers, when we multiply them, I get negative 24, that was my C, my AC. Now that we have that, we will introduce here the factor by grouping. And by grouping, we need to remember that we need to have 4 terms. So we're gonna create them. So we're gonna rewrite the B term, this B term. We're gonna rewrite it using the two terms, the two numbers that we got. So in step 3, we're gonna rewrite the B term, but we're gonna be using the numbers in step 2, okay? So here's what we're gonna be doing. So we have a 4x squared plus 5x minus 6. So this one, like it says there, using the two terms that we found. So we found at 8x and we found a negative 3x. This doesn't change, the 4x squared minus 6. Okay. Now, what are we doing? We're going to be factoring by grouping. So then, let's do that. Here is 4x, and I have an x left, and I have a 2 left. So 4x is my greatest common factor. I factored it. And now for this one, it's going to be 3x. I'm bringing this negative down. If I multiply this negative 3 times x, I get negative 3x, right? And if I multiply this one times 2, negative 3 times 2, is it going to have to be positive or negative? It's going to have to be positive in order for me to multiply it and to get negative 6. That is the same as this one. Now, factor out the x plus 2, and what do I have left? 4x minus 3. And we got to the same one, the same answer as we did it here. To me, I find it longer. I don't know. This is my opinion. You guys can decide what you want to do. So this part is just by grouping. Before that, you find the AC. Before you find the AC, which is multiplying the coefficient A and the coefficient C. And based on that, plus the middle term, you find the sum and the product. Having those two numbers, you're going to divide the B term into two terms. And then you're going to do by grouping. All right, let me do another one. 5x squared. Yes, let me do the next. Go ahead.
Yeah, can we do one more of the AC method?
Yes. Yeah. Not the AC, the box. Oh, okay, I'll do it both ways.
Okay. Okay, thank you.
Okay. Let's do this one. This one. Factor 5x squared plus 29x minus 42. Oh no. Okay, no, I don't have. So let's do that. I have this one. So we're gonna do the box method. So the box method says we're just gonna create a box. The first term is gonna be 5x squared, and the last one is gonna go here, minus 42. Okay, so we're gonna multiply this one times this one. So what do we get? Negative 210x squared. So we need to find a number, two numbers, and when we multiply, we get negative 210. And when we add them, we get 29x. So then let's find this number. So we have negative the 210. So 210 would be 1 times 210 divided by 2 would be 105 divided by 3 will be 70. But none of these ones, when I add them, I get 29. Let's do it. 4 doesn't go there. 5 goes there 42 times. We add them, I don't get 29. So let's do it by 6. 6 goes in there, so it's going to be 35. So 6 minus 35 is going to be 29, right? If this is negative and I multiply by this one, I get negative 210. And if I add them, I get positive 29. Another way that we could do this is what I was doing before, the 3 method. So we go back and we do 2 times divided by 2. That's 105. Now, divided by, we cannot do it by 2, but we could do it by 3. That would be 35. 35 divided by 5, and that's going to be 7. So here's a combination of, we know that this one is 2 times 3 times 5 and times 7. 6 times 5 is 30. 30 times 7 is 210. So we could play with these numbers here too. If we multiply this 2, we get 6. If I multiply this 2, I get 35. 6 times 35 will give me the 210, and if I subtract it, will give me the 29. So you could use the 3 method or do it this way. Or the calculator too. So now we have, let me write down, we're gonna do,
Could you slide your paper up a bit?
yeah, sorry, negative 6x is gonna go here, and 35x. It does not matter where they go. You can just switch in. I just wrote it down there, but I could write it down here, this negative 6, and the 35 here, x, okay? I found, I just went to YouTube and I tried to find a ways to explain the box method. And this one was the easiest way that I found there, okay? So then now, let's do Let's find the greatest common factor. So we're gonna do this part. What is my greatest common factor? Let's do we were doing rows first. So right here, what do we have in common? Just the x. And what do we have in common here? 7 times 5 and 7 times 6. So it's going to be a 7. What do I have in common here? A 5 and an x, right? And here I have a 6. There we go. Now let's see the signs. If I multiply this x times this 5x, I get positive. So if I multiply this x times 6, I need to get negative 6x. So this is going to be negative. Let's go down and do this one. 7 times 5x is going to be 35x. And 7 times negative 6 is going to give me negative 42. So this is the one that needs to be negative, and this is the one that is going to be positive. So my answer is going to be x minus 6, x plus 7. And I just factored the trinomial. I just did it. The answer is going to be this one and this one. It does not matter the order at all. Okay?
So we'll be required to do all the three methods or whatever the methods we just followed, or just whatever we can just do whatever we feel easier. During test and assignment.
Yes. So with the first one that we did, what did I do with that? Oh, right here. So we use the first method when we're doing trinomials of this type, the quadratic function, the quadratic form. If we have a 1 here, you guys are going to use the sum and the product method. Second, if we don't have a 1 there and we have just like this one, that you have a coefficient of 5 and you cannot factor it out, so then you're going to use the box method. Either the box or the AC. This is called AC, box or AC method. Either one you're going to use. Again, I like the box. Now, the third method that we're going to be covering is the substitution method. So let's do that one. And I'll show you where to use the substitution, okay? So we're going to factor quadratic. But if we look a little bit closer,
You're cutting out quite a bit.
Oh, okay. Okay, let's try now. Thanks for letting me know, okay? So, going back, when we look at this, it doesn't look like a quadratic. However, when we look closer, it is quadratic form. It follows the general quadratic form. Let me reload. That's what it's asking me here. So I'm going to do that, all right? I'll be right back.
Yeah, no.
Okay.
All right, now I'm back. So it says that what I was saying, that it follows the general quadratic form, this one, even though it doesn't look like it, because look at this. It does. So instead of writing the x plus 1, so I'm going to write that down here. Instead, so instead of writing the x plus 1, we will write y, okay? So we're substituting y for x plus 1. That's what we're doing. So let's rewrite the problem with the substitution that we just did. So let's do that. So we have 3. Hold on, let me write the problem again down here. And we're going to let y be equal to x plus 1. So it's going to be 3y squared minus 7y minus 20. So we're going to substitute this for y. All right? Now, let's solve it. Yeah, let's solve it. Did I take it back here? No. Okay, so let's do it. And I'm going to do it using the Bax method. Okay? So let's get the Bax there. Write the first term here, the last one here, okay? And we're going to say, we're going to multiply it. 3 times 20 is going to be negative 16y squared. And when we add it, it's going to be negative 7y right here. So let's find those two numbers. So we have 60 times 2 will be 30, times 3 will be 20, 5 will be 12, right here. Because when I multiplied 12 times 5 will be 60. And if I subtract 12 minus 5, that's going to give me a 7. Let me see. But this one will have to be negative and this one positive, right? When I multiply them, I get negative 60. When I add them, I get negative 7. Yes, that's the two numbers. So then negative 12y and the 5y is going to go here. Now, let's get the numbers. Let's factor that out. So right here, what is my greatest common factor? It's going to be 3y. And what is my greatest common factor? On this one is going to be 5. On this row is going to be just the y. And here is going to be between 12 and 20 is going to be a 4. Now, let's see the signs. If I multiply y times 3y, what do I get? 3y squared. If I multiply the 5 times y, I get 5y. So this is going to be positive. Let's see this one. If I multiply the 4 times 3y, it needs to be negative. So this has to be negative. If I multiply negative 4 times 5 will give me negative 20. So my answer is going to be 3y plus 5 multiply y minus 4. But we're not done, okay? Hold on. We're not done yet. We need to go back. This is written in terms of y. And our problem was in terms of what? X. So we need to replace y. So let's go back and do that. We have 3x plus 1 squared minus 7x plus 1 minus 20. That was our original exercise. Okay, I'm just writing it down here. And the answer that we got was 3y plus 5 and y minus 4. But don't forget that we said that we were going to let y be equal to x plus 1. We said that y was going to be equal to x plus 1. So let's do that. So this is going to be 3 times what? What is y? X plus 1 plus 5. And then this one, what was y? X plus 1 minus 4. Okay, so I'm replacing the y with x plus 1. I just did it here and here. Okay, so now it's a little bit more work. Now I'm going to have to distribute the 3x plus 3 plus 5. And this one is going to be x plus 1 minus 4. So this is going to be 3x plus 8. And this is going to be x minus 3. And this is going to be the answer. So when we have to substitute, yes, it's going to be a little bit more work. Any questions, guys? Okay. Emily?
Nope, all good.
All right. Um, that's what I have for you guys today. And tomorrow, according to my, gosh, the week is going so fast. According to my schedule, we're gonna be doing 6.3, which is factor special products. We'll be doing that. Any questions from the homework? How are we doing in the homework?